Hello friends, so in this video we are going to discuss analysis of variance, or it is also called ANOVA. So ANOVA test we use when we have 3 or more samples. So whenever we have 3 or more samples for testing, we use our ANOVA. The null hypothesis that we test in ANOVA is we assume that the mean of all the 3 samples or whatever n number of samples we have is equal. And the alternate hypothesis, we assume that at least one of the mean differs. So now here, the name is analysis of variance, but if you look at the hypothesis, we are writing the hypothesis in terms of mean. So why it is called analysis of variance is because we use the variance to test our hypothesis. So here we use F test for testing our hypothesis. So the formula for F test is we take ratio of variance. So we have variance 1 upon variance 2. So we take ratio of 2 variances to find out our test statistic value, that is F value. Now which are these 2 variances that we will be evaluating? So our variance 1 is we will check what is the variation between the samples. So whatever number of samples we have, we will check how much variation is there between the samples. And our second variance, we will check how much variation is there within the sample. So variance 1 is variation between the sample, and the variance 2 is variation within the sample. Now, if you remember the formula for calculating the sample variance is summation xi minus x bar square upon n minus 1. So now in this formula what we will do is, if you see our numerator is just the sum of squares. So we can take our numerator as sum of squares and the denominator is n minus 1. So in testing of hypothesis, this n minus 1 represents the degree of freedom. So we will calculate our variance by sum of squares upon degree of freedom. Now since we are not using the exact formula of variance, we will call this as mean sum of squares. So we are finding the mean of all the sum of squares. Now how we will calculate this? So here we use something called as ANOVA table. So in ANOVA table, first we write down the values of sum of squares. Then we find out the degrees of freedom. Then we have mean sum of squares, and then the test statistic value or F value. So how many variations we are having? So first, as we discussed, we will find out the variation between the samples, and the second we will check variation within the samples. So we will find out the 2 variances, variation between the sample and variation within. So we will find out the sum of squares, and then we will find the degree of freedom, mean sum of squares. So this we will calculate by sum of squares upon degree of freedom. So we will have mean sum of squares 1, that is between the samples, and similarly for the second within the samples we will have the second mean sum of squares, and our F value will be mean sum of squares 1 upon mean sum of square 2. So this will give us our F, that is the test statistic value. So we are checking the variation between the sample and variation within the sample. We can add one more row over here is the total. Total is nothing but the addition of this 2 sum of squares and this 2 degrees of freedom. So this is the example that we are solving. So there is a nutritionist who has 3 types of diet plan, and he want to compare whether the weight loss done by each diet plan is same or whether there is any difference. So we want to check whether there is any significant difference in the diet plans. So the weight loss for all the 3 types of diets are given over here for diet A, B and C. So now what we want to do is we want to analyze whether there is any significant difference between the weight loss. So the first thing that we will do is we will first find out the mean of all the samples. So if you look at the first sample for diet A, when we calculate the mean for this, it will come out as 9.2. Similarly for diet 2, x2 bar it will come out as 9.15, and for the third sample the mean x3 bar comes out as 11.05. And we will also need the grand mean. So the grand mean x bar will come out as 9.8. So these are the means that we have calculated from our given data. Now we will calculate the sum of the squares. That is our numerator of the variance. So here we will be calculating the two sum of squares. The first one we label it as SSC. It is the sum of squares between the columns or between the samples. So the formula that we are using for calculating this sum of squares is summation ni into xi bar minus x bar square. So here ni represents the number of data points that we have in the sample, xi bar represents the sample mean, and x bar is the grand mean. So we are taking the variation of the sample from the total data. Yes, so we are checking the variation between the samples. What is the meaning of variance? We find out the variation of our data from the mean. So same thing we are doing over here. So here for the first sample, the value of n, the number of data points, if we calculate 1, 2, 3, 4, 5. So we have 5 points over here. So 5 xi bar, the first way, the mean that we are getting is 9.2 minus x bar. X bar, our grand mean is 9.8 square plus second sample 1, 2, 3, 4, 5, 6. So there are 6 data points. The mean is 9.15 minus 9.8, that is x bar. Fourth sample 1, 2, 3, 4. We have 4 points. So 4 into sample mean 11.05 minus 9.8 square. So on calculating this, we get the value as 10.34. Next, we will calculate the second variance. So for second variance, we will need the second sum of squares, the sum of squares between the error. So this, our formula is double summation xij minus xi bar square. So here what we are doing is we are trying to calculate what is the variation within the sample. So first one was between the sample and the second is variation within the sample. So when we are calculating variation within the sample, each data point xij we will subtract from the sample mean. So we are checking the variation of the data point from the mean of the sample. So for the first sample, we need to do this for each sample. First sample, the first data point, the value is 9.9 minus sample mean 9.2 plus second point is, square. Second point is 9.6 minus the sample mean 9.2. Similarly, we will do for all the points. Then we will take the second sample. So the second sample, first point is 9.5 minus the sample mean 9.15 square. Here also we will do for all the points. And then for the third sample, 10.8 minus the sample mean 11.05 square. Here also we will do for all the points. So on calculating this, we get the value of SSE as 15.32. So after calculating the sum of squares of column and sum of squares of error, we calculate SST. SST is given by SSC plus SSE. So we have already calculated these two values. So we get the value of SST as 25.66. Okay, next thing what we will do is we need to identify the degree of freedom. So degree of freedom for column, it is C minus 1. C is the number of samples that we have. So here we have 3 samples, 3 minus 1, 2. Next, degree of freedom for error, it is n minus C. N is the number of data points that we have. So total there are 15 data points minus the number of sample 3. So this will come out as 12. And the degree of freedom for total is n minus 1. So it is 15 minus 1, 14. Okay, now we can start with our steps of hypothesis. So the first step, we'll write down the null hypothesis, that is mu1 equals to mu2 equals to mu3. So we are assuming in our null hypothesis that the mean of all the 3 samples is same. That is, weight loss across all the 3 samples is same. Next, alternate hypothesis. We will assume that at least one of the mean differs. Okay, so second step, we will calculate the critical value. So for critical value, we are taking the level of significance alpha as 5%. So we will get the critical F alpha value as 3.8852. Now this value we are getting from the table. This value comes from the F distribution table. So if we will use the F distribution table, we will get this value. After doing this, the next thing is we will form our ANOVA table. So we have sum of squares, degrees of freedom, mean sum of squares and F value for columns, error and total. So SS value for column we have already calculated. It is 10.34. For error it is 15.32 and total is 25.66. Degrees of freedom we have 2, 12 and 14. Mean sum of squares, our formula is sum of squares upon degrees of freedom. So for first one it will be 10.34 upon 2, that will come out as 5.17. For the second error we have 15.32 upon 12, that will come out as 1.277. So our F value will be mean sum of squares of column upon mean sum of square of error. Whenever we are calculating the F value in ANOVA, the denominator is always error. So this will come out as 5.17 upon 1.277. So that will come out roughly as 4.049. So now this is our test statistic value. So in our step number 4, we will calculate this. We will compare our test statistic value with the critical value. So the critical value is 3.8852. So this is our F distribution. The shaded region is the region of rejection and the non-shaded is region of acceptance. So if you look at the value that we are getting, 4.049 will fall somewhere over here. So our value of F is greater than F alpha. So therefore it falls in region of rejection. So therefore we reject our null hypothesis. So our null hypothesis was mean of all the 3 samples is same. So we are rejecting. That means at least one of the mean differs. So we can conclude that the weight loss for all the 3 types is not same. There is a difference in all the mean. Now here we cannot analyze which sample mean differs. For doing that, we can use a graphical analysis. We can use a box plot method to analyze which sample mean differs. Okay, so if you have stayed back and liked this video, please press the like button and subscribe to the channel. Thank you for watching.